This is half past paper higher, week 18, and these are all the topics that we're going to do today. This is a calculator paper, so we've got all of these topics here, the Sparks codes if you have access to Sparks, and all of the even numbers this week. We've got 37 marks on this paper, so 43 marks were on last week's paper, all the odd numbers last week, all the even numbers this week. So let's get into it. Question number 2. Andy cycles a distance of 30 kilometres at an average speed of 24 kilometres an hour. Before I go any further, I'm going to draw my speed, distance, time triangle. So speed, distance, time. If I want distance, I would do speed times time. If I want speed, you'd cover that up and do distance divided by time, and again if you want time, distance divided by speed. So there we go, that's really helpful. He then runs a distance of 12 kilometres at an average speed of that, work out the total time. So if we want time, we would cover up the t, and it's going to be distance divided by speed. So let's first look at his cycling. This is a bike, believe it or not. There we go, there's a bike. So we're going to do distance, which is 30, divided by his speed, which is 24. Now I am going to use my calculator for this. 30 divided by 24 is 5 over 4. 5 over 4, 5 quarters, 1 1/4, that's quite key, or 1.25. Okay, good, we'll come back to that in a second. Then he's going to run. Oh dear. Oh no, I've broken his leg. Anyway, you get the idea. Maybe that way. Yeah, that way. There we go. He's running. And then we're going to do 12 kilometres, an average speed of 8. So 12 divided by 8 is going to be 1.5. Now, those times are in hours. You did distance in kilometres and you divided it by the speed in kilometres per hour. So matching up the units, the time would need to be in hours. So we've got 1.25 hours and 1.5 hours. Now think very carefully. 0.25 of an hour is not 25 minutes. It is a quarter, same as we've got here. So an hour and a quarter, 1 hour and a quarter is 15 minutes. So that's 1 hour and 15 minutes for that one. It's not 25 minutes. It's a quarter of an hour, which is 15 minutes. And then 1.5, again, that's not an hour and 50. It's an hour and a half. So 1 hour 30 for that. Adding these together then, how long did it take him all together? It is 2 hours and 45 minutes in total for 3 marks. Question number 26. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 by 9 metres. So we've got rectangular lawn 5 metres, 9 metres, which is 45 metres squared. Remember, we do base times height for area, and that needs 3 kilograms of grass seed. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 by 14. Okay, so way bigger. Oh, that's terrible. 10 metres here and 14 metres here, which would be 140 metres squared. She's got 5 boxes of grass seed. Has Maisie got enough? Okay, so we know that 3 kilograms covers 45 metres squared. She wants to cover 140 metres squared. So how many kilograms would that be? Okay, so 1 kilogram covers 15 metres squared. I've got that by dividing by 3, and there's lots of different ways you can do this question. This is just the way I've decided to do it. Every kilogram of grass seed covers 15 metres squared. So to get 140 metres squared, let's do 140 divided by 15, and that will tell us how many kilograms she needs. So that's 9.3 recurring. So 9.3 recurring kilograms. That's how much she needs. And she has 5 boxes, and there is 2 kilograms in each. So 5 times 2 is 10 kilograms. That's what she has. She has 10 kilograms. She needs 9.3 recurring kilograms. So has she got enough? Yes, she has. She's got enough. There's lots and lots of ways you can do that question. So if you did it in a different way, don't worry. But you do need to make sure you answer the question. So has Maisie got enough grass seed to make a lawn? And you say, yes, she needs 10 kilograms. No, she needs 9.3 kilograms and has 10 kilograms. Perfect. Maisie opens the 5 boxes of grass seed. She finds that 4 of the boxes contain 2 kilograms. And 1 of the boxes has only 1 kilograms in it. So 4 times 2, that's 8. Add the extra 1 is only 9 kilograms. Does this affect whether Maisie has enough grass seed to make her lawn? Yes, she needs 9.3 recurring kilograms and only has 9 kilograms. She does not have enough. There we go, so that changed your answer. Wonderful. Question number 28. Use these graphs to solve the simultaneous equations. So this line here is labelled with that equation. So that's the equation of that line. Same here, this line here is labelled y equals minus 2x. So that's the equation of that line. Now every single coordinate on this line makes this equation true. I'll show you what I mean. So if you were to take this coordinate, for example, up here, that is the coordinate minus 4, 8. That's that coordinate just up here. If you put minus 4 here, where the x is, because that's your x coordinate, and you put 8 here, where the y is, because that's your y coordinate, does 8 equal minus 2 times minus 4? Yes, it does. Now, every single coordinate on that line would make that equation true. But if you were to pick a random point, like 2, 2, it wouldn't work. 2 does not equal minus 2 times 2. So if a point lies on the line, it will make the equation true. It's x and y. And so if I would like to solve both equations, I'm just looking for a coordinate that solves both equations. And that's going to be here. I'm simply looking for the point where they cross, because we know that that point lies on both lines, so it would make both equations true. Now at that point, it's minus 2, 4. Minus 2, 4 is your coordinate there. Remember, along the corridor up the stairs, that's your x coordinate, that's your y coordinate. Therefore, x needs to be minus 2 and y needs to be 4. And that would make both of these equations work. And you could check by substituting them in, but you don't need to. For simultaneous equations, you're just looking for the point where both graphs cross. And then we have this, use this graph to find estimates for the solutions of the quadratic equation x squared minus 4x add 2 equals 0. So they're telling us here that this is the graph of x squared minus 4x add 2. And then they're saying, when does that exact equation equal 0? Now I want you to imagine that equaling 0 is the same as crossing the floor, for example, this x-axis. That is where it equals 0. It's often called the roots, and it's often called the solutions. So we're looking for the x coordinates, just the x coordinates, because we're trying to solve this equation, and this equation has no y's in it. They're not asking you for coordinates, they're asking you for solutions. When does it equal 0? And so firstly, let's have a look here. That would be 0.6. And secondly here, we would get 3.4. Those would be your answers for 2 marks. Question number 8. There are some counters in a bag. The counters are blue or green or red or yellow. The table shows the probabilities that a counter taken at random from the bag will be blue or it will be green. So we've got those probabilities given to us. And we know that probability adds up to 1. So I know that whatever these 2 values are here, it's going to need to make sure that these all add up to 1 altogether. The probability that a counter taken at random from the bag will be red is 5 times the probability the counter will be yellow. So there's a couple of different ways you could do this. You could say that they're in the ratio 5 to 1, or you could call it 5x and x. Either way, you're going to get the same answer there. So let's add up what we've got so far. First step would be to do 0.32, add 0.2, and that is 0.52. If we take that away from 1, 1 take away 0.52 is 0.48. So that's what I've got to share here. 0.48 needs to go over those two lines. So 0.48. Therefore, I either know that 6x equals that, and you can divide by 6 to get x, or you can say we need to share that 0.48 in the ratio 5 to 1. So think 1, 2, 3, 4, 5, 1. So again, we're going to be dividing by 6, sharing it over those lines. Either way, you're going to be doing 0.48 divided by 6, which is 0.08. That goes on each of those little lines, 0.08, 0.08, or you can say x is 0.08. Either way, I get 0.08 there, and 5 lots of that would be 0.40 or just 0.4. So that's going to be your probability of red. There are 300 counters in the bag, so how many of them would be yellow? Well, this is my probability of yellow. So we're saying 8% of the counters are yellow, or 0.08, that's the proportion that is yellow. So the easiest way to do this is to say 300 multiplied by 0.08, or you can just do 8% of 300. So 300 times 0.08 is going to be 24 yellow counters, and that would be your answer for that one. So that was 3 marks there. 24 would be your answer. Question number 10. A person's heart beats approximately 10 to the power of 5 times each day. A person lives for approximately 81 years. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form, correct to 2 significant figures. So this is an estimate because we don't know how long that person's going to live, but we're roughly working it out based on an average lifetime of 81 years. So we're going to do 10 to the power of 5, that's in one day, times by 365 days in a year, and we're timesing that by 81 years. So timesing all of that together, I'm just going to type that on my calculator, 365 times 81 times 10 to the power of 5, and in my calculator I get 295650000. Be careful when you're counting those zeros. Now it says give your answer in standard form, correct to 2 significant figures. So we've got 5 digits here, but we only want 2 significant figures. That's your first significant figure, that's your second significant figure. Chop there, check the next number, and 5 rounds up. So this is actually going to round to, we'd want to make the 9 10, but we can't, so it's going to be 3.0 times 10 to the power of, and how many times would we need to times it by 10 to get the decimal point from there to there? Now, it's not the decimal point moving, it's the values, but it's way easier to move a decimal point than it is to move all those numbers. So there we go, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3.0 times 10 to the power of 9 would be your answer there for 2 marks. Part B says 2 times 10 to the power of 12 red blood cells have a total mass of 90 grams. So I'm going to write 2 times 10 to the power of 12 equals 90 grams. Work out the average mass of 1 red blood cell. So this is 2 times 10 to the power of 12 red blood cells, but I just want 1. On that left hand side. So what have we done? We've had to divide the number of red blood cells by 2 times 10 to the power of 12. And if we've divided that side by 2 times 10 to the power of 12, we also have to divide the other side by 2 times 10 to the power of 12. So in my calculator, I am typing 90 divided by 2 times 10 to the power of 12. Now you might find it easier to write that as a fraction to make sure you're dividing by all of that, or you can put it in brackets, that's absolutely fine. But either way, you want to divide by all of that, and that is 4.5 times 10 to the power of minus 11. Now, that's a really small number, but that's what we were expecting. This is the mass of 1 red blood cell. It's going to be tiny. So there we go. Give your answer in standard form. We've already got it in standard form. That's how it comes in our calculator. So 4.5 times 10 to the power of minus 11. Okay, question 12a. Express x over x add 2, add 2x over x minus 4 as a single fraction in its simplest form. So when we add fractions, we want to make the denominators the same, and the easiest way to do that is to times them together. So this denominator is going to be x add 2 times by x minus 4. We're multiplying them together. Now to do that, I've times the bottom of this fraction by x minus 4, so I also need to times the top by x minus 4. So that's x, open brackets, x minus 4 over there. And then I need to add, now with this fraction, I've times the denominator by x add 2, so I also need to times the numerator by x add 2. So 2x, open brackets, x add 2. Expanding out those brackets. Now, you could expand out the bottom, but I wouldn't worry about it. If things factorise, then they can simplify. So you probably want it factorised rather than expanded on the denominator. This is going to be x times x is x squared minus 4x. And then I've got add 2x squared, add 4x. And that's all over. And like I said, I'm going to leave this factorised just in case we get something to factorise on the top, and that's going to be 3x squared coming from here and here, and then I've got minus 4x, add 4x, and those two terms are actually going to cancel each other out. So my final answer is going to be 3x squared over x add 2, x minus 4. And you might have expanded out the denominator, it wouldn't matter. You'd be absolutely fine with that either way. So there we go, that's your final answer for 3 marks. Can't simplify that anymore. And then for part B, we need to expand 3 brackets. Now to expand 3 brackets, you're saying you've got the first bracket times the second bracket times the third bracket. So I'm going to start by doing x minus 3 times 2x add 3. I'm just going to times those first 2 brackets together. X times 2x is 2x squared. X times 3 is 3x. Minus 3 times 2x is minus 6x. And minus 3 times 3 is minus 9. So that is 2x squared minus 3x, coming from these two terms, take away 9. Okay, so that is my first 2 brackets simplified. And I now want to times that by 4x add 5. Now it's at this point that a lot of students find it easier to do it in a table. So I'm going to put 4x add 5 going down, and I'm going to times that by 2x squared minus 3x minus 9. You don't have to do it in a table, but I think a lot of students do find this easier. So 4x times 2x squared is 8x cubed. 4x times minus 3x is minus 12x squared. And here we've got minus 36x. Down here, I've got 10x squared minus 15x, and I've got minus 45. And we're now going to collect up those like terms, and you can see them there and there. So my final answer is going to be 8x cubed, that's the only x cubed term, minus 2x squared, minus 51x, coming from these two, and then minus 45 for 3 marks. Question number 14. Points B, D, E and F lie on a circle. So they're all on the edge of the circle, and that means already that I know this is going to be a cyclic quadrilateral because all 4 corners of that quadrilateral are touching the edge or the circumference of the circle. So ABC is a tangent. Find the size of angle ABD. You must give a reason for each stage you're working. So ABD, you're going from A to B to D. So the angle that they are asking you about is this one here. So I'm going to put an X there just so that we know what it is we're working out for the question. And then I'm going to fill in as much as I can using my circle theorems. So the first one that jumps out at me is this one here. And this is 80 degrees. Reason I know this is 80 degrees is because, like I said, we've got this cyclic quadrilateral where all 4 corners of the circle touch the edge of the circle, the circumference, and opposite angles in a cyclic quadrilateral add to 180. So that's what I need to say. Because this one's 100, I know this one's 80, because opposite angles in a cyclic quadrilateral, a quadrilateral in a circle, add to make 180 degrees. So that's my first step. Now the next thing you have is you actually have a triangle here. Again, you've got the 3 corners of the circle touching the edge of the circle, and you've got a tangent here. So when you have a triangle on its tip on the tangent, okay, that is the alternate segment theorem. And what happens with the alternate segment theorem is this angle here is actually the same as this angle here. So I know that that one is 40 degrees, and all I need to say for that is alternate segment theorem. And that's enough for that. And then I've just got angles on a straight line. So looking at what we've got so far, let's change back to blue. I've got 80 add 40 is 120, and 180 take away 120 leaves me with 60 degrees. So my answer here is 60 degrees, and my reason is angles on a straight line add up to 180 degrees. There we go. So that's it, 4 marks there for that. I find it much easier just to annotate the diagram with your reasons. You can write down here like angle ABD equals 60 because, and that's absolutely fine. But as an examiner, it's much easier for me to see your reason on the graph, on the diagram there with the working out, just a lot easier to see. So there we go, 60 degrees for that one, and you had to give all the reasons. Question number 16. Here is a speed time graph for a car. Work out an estimate for the distance the car travelled in the first 30 seconds. So remember, speed, distance, time. Is your triangle, and so if you think about that triangle, speed, distance, time, if you want the distance, it is speed multiplied by time. So that's this axis multiplied by this axis. So hopefully it makes sense if I say what we're going to do here is work out the area underneath the graph. Now in the first 30 seconds means I just want the area of this section here. And because I can't work out the area underneath a curve, I've got to turn it into a triangle to estimate this. Now, I think that this value here is feeling like 9 to me. So remember, for the area of a triangle, we're doing base times height divided by 2. Your base is 30, your height is 9. So base times height divided by 2 is 30 times 9. Divided by 2 because it's a triangle, so that's 270 divided by 2, which is 135. Now, if your speed is in meters per second and your time is in seconds, then that distance is going to be in meters. We've got that on the answer line, so I'm happy that that is 135. Is your answer to part A an underestimate or an overestimate? Well, look at the area we worked out. We worked out the area of that. So there was a little slither there that did not get included, okay? So our answer is going to be an underestimate. I'm going to say underestimate as some area was not included in our calculation. Fabulous. There we go. 3 marks for that. Julian used the graph to answer this question. Work out an estimate for the acceleration of the car at time 60 seconds. So if we want the acceleration, he's done speed divided by time, 13 divided by 60, 0.216 meters per second squared. Julian's method does not give a good estimate of the acceleration at time 60 seconds. Explain why. So acceleration is the rate of change of the speed. It's going to be the gradient. Now, he wanted the acceleration at 60 seconds. So we go to 60 seconds and we go to this point here. He's read that off as 13. So he's done 13 divided by 60, okay? Now, what we actually want to do, if we want the acceleration, is we would need to do a tangent at that point. Oh, I'm going to go a bit lower there and move it up. So I want to kind of match that gradient at that point. Turn it into a triangle and do rise over run. So he has not calculated the gradient at that point, which is what he would need to do to get the acceleration. So we need to say he should have drawn a tangent to accurately calculate the gradient, which is what would give you the acceleration. So there we go, that was your 4th mark on that one. Question number 18. The diagram shows a cube. A to H is 11.3, correct to the nearest millimetres. So this is a bounds question. We've got rounded values. If we've rounded to the nearest millimetre, that's the same as 0.1 centimetres. So your upper bound is 11.35. Let me go 11.3. 11.35 is your upper bound, and 11.25 is your lower bound. That's the biggest and the smallest it could have been to be rounded to 11.5. And that is A to H. So that's going to go across there like that. Calculate the lower bound for the length of an edge of the cube. Okay, so we know to get that value, we would need to make a right-angled triangle like that. And we can make another right-angled triangle here, like that on the floor. Okay, so if I say that E to H is X, and because this is a cube, this side is also going to be X, and because this is also a cube, that side's going to be X, okay? So I would do X squared, add X squared, square root my answer to get this value here, and then I'm going to square that again. So that would be squaring this, which is going to just be X squared add X squared, so that's 2X squared. Add another X squared, and then square root that, and that's going to give me either 11.35 or 11.25. Now we want the lower bound. So to get the lower bound, we're going to want to use the shortest version that we can, okay? So that would need to equal 11.25. And because they're all the same, it's that. So we've got the square root of 3x squared equals 11.25. So let's work backwards here. I'm going to start by squaring both sides. 3x squared equals 11.25 squared. Oh, turn my calculator off, try again. 11.25 squared is 126.5625. Divide that by 3. And that is x squared equals 42.1875, and then square root your answer. So that is going to be x equals 6.49519058. Now I'm not going to round that because we are trying to give the lowest it could be. So I kind of want to write all of that. I think normally on the mark scheme it says 5 decimal places when you're doing bounds questions, but I'm not going to risk it. I'm just going to write them all. Because I can. Why not? It doesn't take that much longer. So if you had a square with that, then that is what would correspond to a diagonal AH of 11.25. But a very difficult bounds question, that one. So well done if you followed along with that. And then the last question on the paper is this one. Here is a list of 5 numbers. We've got 98 to the power of 53, 98 to the power of 64, 98 to the power of 73, 98 to the power of 88, and 98 to the power of 91. Find the lowest common multiple of these 5 numbers. So I think the easiest way to show this is actually to make the numbers much smaller and just show you what's happening. So if I had 3 to the power of 1, 3 squared, 3 cubed, 3 to the power of 4, and let's just do 3 to the power of 5 just because we can, then this would be 3, 9, 27, 81, and 243. Now if I asked you for the lowest common multiple of these numbers, I'm asking you for the first number that's in the 3 times table, and also in the 9 times table, and also in the 27 times table, and the 81 times table, and the 243 times table. Now, 9 is always going to be in the 3 times table, and 27 is always going to be in the 9 times table. 81 is always going to be in the 27 times table, and 243 is always going to be in the 81 times table. All of these numbers are factors of the bigger numbers because they all go into it an exact number of times. So all we need to do here is look for the one with the highest power, because all of the others are going to go in, and that would be the lowest common multiple of those 5 numbers, because that's going to be the first number that is in all of their times tables. So that's going to be 98 to the power of 91 as your answer for that last question. I don't love that last question. I find it really hard to get my head around. So if that didn't make sense, don't worry too much. That was it. So all of the questions, 37 marks on that one. And that was all the even numbers. If you've got any questions at all, I'd be more than happy to help. Drop me a comment down below and I will help to go through it where I can. I hope you enjoyed it, and I will see you guys next week for week 19.